The alarm fires at 7,000 feet. Yellow light. 1202, 1202. The computer is screaming a code Armstrong has never seen outside a simulator, and the simulator times it killed them. The Eagle is falling toward a surface no human has ever touched, and the machine that is supposed to land it is overloading in real time. In Houston, a 26-year-old named Steve Bales has 18 seconds to decide whether two men live or die. He says go. The alarm fires again and again. The lunar module keeps descending toward a field of boulders the autopilot is steering straight into, and Armstrong reaches up and takes the controls by hand. 25 seconds of fuel left. This is the moment the world celebrates. It is also the moment the moon almost won. Now stop for a second. Wherever you are watching this from, whatever time it is where you live, ask yourself honestly what you were taught about Apollo 11. A clean triumph, a flag, a line about giant leaps. That is the version that fits on a postage stamp. The version inside the mission transcripts is different, and once you read it carefully, you cannot unread it. The 1202 alarm was not a glitch. It was the Apollo guidance computer telling the crew it had been handed more data than it could process, because the rendezvous radar had been left in the wrong position and was flooding the system with information it did not need. The computer survived because its software had been written to shed lower priority tasks under load. It was designed for failure. Think about what that sentence means. The engineers who built the brain of the lunar lander knew, before launch, that the most likely outcome of a real descent was that the brain would be overwhelmed. Their solution was not to prevent the overload. It was to teach the machine to triage in the seconds before impact. That is not the story of a routine mission. That is the story of a controlled near failure that ended well because one pilot was good enough and one engineer was calm enough. The official story of Apollo 11 is the one you can recite without thinking. A crew of 3, a landing, a walk, a flag, a return, a parade. It is a story shaped for a stamp, a textbook page, a 30-second clip on an anniversary broadcast. And like every story shaped for those formats, almost everything that makes it interesting has been sanded off. Read the actual post-flight technical debrief and a different document appears. Armstrong's heart rate during the powered descent climbed to around 150 beats per minute. That is not the pulse of a man performing a routine maneuver. That is the pulse of a man fighting his vehicle. Aldrin, calling out altitude and velocity beside him, was operating on the same adrenaline. Two pilots, in a thin aluminum can, in a place no living thing had ever been, with a computer that had just told them twice that it was drowning. Now think about what was happening on the ground while that descent unfolded. The Nixon White House had already commissioned a contingency speech. The text exists. You can read it. It begins with the line that fate had ordained that the men who went to the moon to explore in peace would stay on the moon to rest in peace. There were instructions for a clergyman to perform a burial at sea ceremony, in the symbolic sense, for two men still alive but stranded. There were instructions for Nixon to call the widows before the speech aired. Let that sit for a second. A government that drafts a eulogy before a flight does not believe the flight is safe. It believes the flight is survivable, which is not the same thing. The public was sold confidence. The internal record was preparing for a corpse on the lunar surface that could never be recovered. And once the lander was down, the danger did not end. Armstrong and Aldrin slept that night in their suits, in a cabin too cold to undress in, sitting on top of an ascent engine that had never once been fired on the moon. Every flight test of that engine had happened in a vacuum chamber on Earth. If it failed to ignite, there was no rescue mission. There was no backup vehicle. There was Mike Collins in orbit overhead, who would have had to leave them and come home alone. This is the part the triumph montage does not include. The two men on the surface were, for several hours, the loneliest human beings who had ever existed. sleeping on a bomb they hoped would work. Then there is the quarantine. When the crew returned, NASA did not simply welcome them home. They were placed inside the lunar receiving laboratory for 21 days, behind biological containment that would not look out of place in a modern infectious disease facility. The capsule was scrubbed. The recovery divers wore protective suits. The president spoke to them through a window. Why? Because NASA could not rule out the possibility that something had come back with them. Not a creature, not a monster, something smaller, a microbe, a spore, a contamination vector. The agency that publicly celebrated the conquest of another world privately admitted in its own protocols that it did not actually know what the world contained. So ask the question the press releases never asked plainly. What were they afraid of? The image most people carry of the moon is a still photograph. Grey, silent, empty. A place where nothing happens because there is nothing there for anything to happen to. That image is wrong, and the wrongness is not a matter of detail. It is a matter of category. The moon is not a passive destination. It is an active radiation environment, and the only reason you are not standing in one right now is that you live underneath a magnetic field you cannot see and an atmosphere you take for granted. Earth has both. The moon has neither. Start with the numbers. On the lunar surface, an unshielded astronaut absorbs roughly 200 to 400 microsieverts of radiation per day from the constant background of galactic cosmic rays. On Earth, at sea level, the equivalent figure is closer to 10 microsieverts per day. That is a ratio of 20 to 40 times higher every single day with no off switch. A transatlantic flight gives you about 50 microsieverts in 8 hours, and people worry about that. The lunar surface delivers a transatlantic flight's worth of exposure roughly every 4 hours, around the clock, for as long as you stand there. Now add the solar wind. Then add solar particle events. In August of 1972, between Apollo 16 and Apollo 17, the Sun fired a particle storm at the Earth-Moon system that would have delivered a dose of several sieverts to any astronaut caught on the lunar surface without heavy shielding. Several sieverts is the range where acute radiation syndrome begins. Vomiting within hours, bone marrow failure within weeks, death possible without aggressive medical intervention that does not exist on the moon. If that storm had hit 4 months earlier or 3 months later, 2 American astronauts would have died inside their suits, and the Apollo program would have ended with corpses on the surface. This is not speculation. This is the dosimetry record. NASA studied it afterward and quietly absorbed the lesson. The moon is reachable. It is not survivable for long. And here is the part that should bother you most, because it is not abstract. Every Apollo astronaut who flew to the moon reported the same strange phenomenon during the coast phases of the mission. With their eyes closed, in the dark, they saw flashes, brief streaks of light, sometimes points, sometimes lines. They were not hallucinating. They were watching cosmic ray particles pass through their own retinas and optic nerves, ionizing tissue as they went. Each flash was a single high-energy nucleus from somewhere outside the solar system, leaving a small, permanent track through cells in their brain. Think about that image. 12 men in a metal can being lit up from the inside by particles that had traveled across the galaxy to reach them. That is what standing on another world actually feels like at the cellular level. The dose can be measured, the flashes can be counted, the damage accumulates. And the radiation was only the part you could measure. The dust was supposed to be a non-issue. Pre-flight briefings treated it as a minor housekeeping concern, the equivalent of tracking sand into a beach house. The engineers had models. The models said the regolith would behave like a fine soil. It did not. Lunar dust is not soil. It is a fine, jagged, electrostatically charged powder created by billions of years of micrometeorite impacts hammering rock into glass shards at a microscopic scale. There has been no wind to round the edges, no water to weather them, no biological process to break them down. Every grain is essentially a piece of broken glass, and the average grain is smaller than a human cell. The Apollo crews learned this the hard way, mission after mission. The dust clung to everything. It stuck to suits through electrostatic attraction, not gravity, which meant brushing it off did almost nothing. It worked its way into seals and joints. By the end of 3 short surface excursions on Apollo 17, the wrist joints of the suits were grinding visibly. The gold visors were scratched, cameras failed, zippers seized. Harrison Schmitt, a trained geologist, brought enough dust back into the lunar module that when he removed his helmet inside the cabin, he had what he later described as lunar hay fever. Sneezing, watery eyes, congestion. He was breathing in pulverized glass at the microscopic scale. Now think about what that means at a longer timeline. Apollo crews spent at most about 3 days on the surface. Their suits were near the end of their functional life by mission's end. The seals were degrading. The fabric layers were abrading from the inside. NASA's own post-mission analysis concluded that a 4th EVA in the same suit would have been a serious risk. Artemis is planning surface stays measured in weeks. Eventual base architectures imagine months. The math does not work. The suits we currently have, evolved from the Apollo designs, cannot survive that exposure without a fundamental redesign. And that redesign has not been built, tested, or flown. The dust problem has not been solved. It has been postponed. And the lungs are worse. Apollo crews coughed for days after returning. Modern toxicology studies on simulated lunar regolith show that the particles are small enough to reach the deepest parts of the lung, where they cannot be cleared. Long-term exposure in animal studies produces inflammation patterns that resemble silicosis. On Earth, silicosis is a fatal occupational disease that takes decades to develop. On the Moon, you would be inhaling the trigger every time you cycled the airlock. The grey powder in the photographs is one of the most aggressive engineering adversaries humanity has ever encountered. And we are planning to live in it. If dust this fine destroys suits in days, what does it do to a base in years? Here is the assumption that breaks every long-duration lunar plan. The assumption is that Apollo proved we can do this, and that going back for longer is just a matter of scaling up what already worked. It is wrong, and the wrongness is not a small correction. It is a category error. Apollo was a sprint. Every part of it was engineered around the shortest possible exposure to the lunar environment. 22 hours on the surface for Apollo 11, 3 days at the longest for Apollo 17. The life support, the suits, the shielding, the food, the water recovery, the thermal management, all of it was sized for a window measured in hours and days, with margins so thin that any modern safety review would refuse to certify the architecture for flight. Scaling that into a 6-month surface stay is not Apollo plus time. It is a different physics problem. Start with radiation shielding. To reduce the cosmic ray dose on the lunar surface to something comparable to a year on the ISS, you need somewhere between 2 and 5 meters of regolith piled on top of your habitat. That is not a wall. That is a buried structure. The mass equivalent, if you tried to launch shielding from Earth instead of mining it on site, runs into the hundreds of tons per habitat module. The entire payload capacity of a Saturn V to the lunar surface was about 16 tons. You would need to launch 10 Saturn Vs just to shield one room. That is why every serious base plan assumes in situ resource utilization. You bury the habitat under the dust you already have. But the dust, as we just established, is the most aggressive engineering adversary on the surface. So the plan is to use the thing that destroys equipment as the thing that protects equipment. The contradiction is not hidden. It is the central unsolved problem of the architecture. Now add life support. The ISS has been operating its water recovery system for over 2 decades, and still loses a measurable fraction every cycle, requiring resupply from Earth. The Moon is 3 days away under the best transit profiles, not the 45-minute orbital window the ISS enjoys. A failure in the recovery loop is not an inconvenience, it is a countdown. Then add the cube-square problem. A bigger habitat needs disproportionately more shielding mass, more power, more thermal rejection surface. The numbers do not scale linearly, they scale against you. This is what scale rupture means. A small mission is survivable because everything that could go wrong has been engineered out by ignoring the long timeline. A large mission has no such luxury. The timeline is the threat. And even if you solved every system problem, you still have to solve the bodies inside the suits. Human physiology is the product of a 4 billion-year argument with one planet. Every organ, every regulatory loop, every reflex was tuned inside a 1G gravity field, beneath a magnetic shield, inside an atmosphere thick enough to filter most of the radiation the sun throws at us. Remove any one of those variables, and the body does not adapt gracefully. It degrades on a clock you can measure in months. The data on this is no longer speculative. The International Space Station has been a continuous human experiment in microgravity since 2000, and the results are sobering. Astronauts lose bone density at a rate of roughly 1 to 2% per month in weight-bearing regions, primarily the hips and lower spine. That is osteoporosis on fast forward. A 6-month rotation can produce bone loss comparable to a decade of aging on Earth, and not all of it comes back. Muscle mass goes the same way. Cardiovascular conditioning weakens. The heart, no longer fighting gravity to pump blood upward, actually changes shape, becoming more spherical. Fluid shifts toward the head. Pressure inside the skull increases. The eyeballs deform. A condition now called spaceflight-associated neuroocular syndrome shows up in roughly 2/3 of long-duration ISS astronauts. Some recover. Some carry the vision changes permanently. Then there is the Scott-Kelly data. NASA's twin study, comparing Scott to his identical twin Mark on Earth over a 1-year mission, found changes in gene expression, telomere length, gut microbiome composition, and cognitive performance. Some reverted within months of return. Some did not. The conclusion the researchers reached, in careful institutional language, was that long-duration spaceflight produces measurable biological changes whose long-term significance is not yet understood. That is the polite version. The blunter version is that we do not know what a year in space does to a human being over the following decades, because the sample size is still too small and the people involved are still alive. Now apply this to the Moon. Lunar gravity is 1/6 of Earth's. It is not microgravity. It is not full gravity. It is an untested middle ground that no human has ever experienced for more than 3 days. We do not know whether 1/6 G is enough to preserve bone, or whether it merely slows the loss. We do not know what it does to the cardiovascular system over months. We have no data. None. And we have not even added the radiation. The ISS sits inside Earth's magnetosphere. Every biological number above was measured under partial protection. On the Moon, you remove that protection and add a constant cosmic ray bath that the ISS never sees. A crew returning from a year on the lunar surface would not walk off the lander. They would be carried. And nobody has solved how to feed them while they are up there. Every long-duration lunar plan eventually collides with the same wall. And the wall is not technological. It is a launch cadence problem.
and no agency in history has solved it. A permanent lunar base needs supplies: food, water, oxygen, spare parts, replacement suits, propellant for return vehicles, medical resupply. The numbers are not exotic. A 4-person crew consumes roughly 30 kilograms of consumables per person per day if you do not recover anything. And even with aggressive recycling, you cannot close the loop completely. Realistic estimates put the resupply burden at several tons per month for a small base. Now look at the actual launch infrastructure. The SLS, NASA's heavy lift vehicle for the Artemis program, has a planned production rate of roughly 1 vehicle per year. 1 per year. Each launch costs somewhere between $2 and $4 billion, depending on which auditor you trust. The GAO has documented this in repeated reports, and the Office of Inspector General has flagged it repeatedly as unsustainable for any long-duration architecture. Starship is the variable that the entire plan is now leaning on. The assumption is that Starship will reach a launch cadence high enough and a cost per kilogram low enough to make lunar resupply economical. That assumption has not yet been demonstrated. As of this writing, no Starship has completed a full operational lunar mission profile. The orbital refueling architecture, which requires multiple tanker launches in close succession to fuel a single lunar variant, has not been flown end to end. Cryogenic propellant boils off in orbit at rates that the design must overcome, and the boil-off problem has not been publicly resolved with hardware data. So the entire sustainable lunar presence is currently riding on a launch system that has not yet performed the mission profile it was designed for. That is not a criticism of the engineering. It is a statement of where the program actually is.
Now compare cadences. Antarctic stations are resupplied roughly twice per year during narrow weather windows, and the supply chain has failed multiple times in the past half-century, requiring emergency airdrops. The ISS is resupplied every 6 to 8 weeks, and even that cadence has had failures. Progress, Cygnus, and Dragon have all had partial losses. The ISS sits 200 miles overhead. The Moon is 1,000 times farther. A single failed launch in a sustained presence architecture is not a delay. It is a starvation timer. The crew on the surface has whatever margin the last successful resupply gave them. If that margin runs out, there is no Coast Guard, there is no airdrop. There is a 3-day transit window at best between the decision to launch and the arrival of help. So why does the public framing still sound so confident? The gap between what an agency says in a press release and what the same agency writes in an internal memo is not a conspiracy. It is a structural feature of how publicly funded programs survive. Funding flows toward optimism. Funding stops flowing toward honesty. Every agency, every contractor, every program manager on Earth knows this, and the language they use in public reflects the incentive. Read an Artemis press release. The word you will see repeatedly is operational. Operational by 2025. Operational by 2026. Operational by the end of the decade. The word implies hardware that exists, has been tested, and is in routine use. Now read the GAO reports on the same program. The Government Accountability Office has documented, in detail, that the actual flight hardware for several Artemis mission elements has slipped multiple years, that the lunar lander variant is years behind its original schedule, and that the spacesuits required for surface operations have themselves been recontracted because the original designs were not ready. This is not a scandal. It is the normal operating gap between aspirational language and physical reality. The NASA Office of Inspector General has been even blunter. The Artemis program's total projected cost, by the OIG's own audits, has grown from initial estimates of around $35 billion to over $90 billion across the first few crewed missions. The cost per launch of the SLS, by the OIG's accounting, exceeds $4 billion. These are not numbers the press releases highlight. They are buried in audit documents that almost nobody outside the aerospace industry reads. Now compare this to Apollo, because Apollo was sold to the public the same way. The Triumph version says we landed 6 times and came home. The honest version is that Apollo 13 was within hours of losing its crew, that Apollo 12 took a lightning strike on ascent that nearly aborted the mission, that Apollo 14 had multiple guidance system anomalies during descent, that Apollo 16 had a service module engine failure that nearly cancelled the landing. Every mission had margin failures the public never heard about until decades later, when the engineers wrote their memoirs. The pattern repeats because the incentive repeats. Public belief in readiness shapes funding. Funding shapes safety margins. Safety margins shape whether crews come home. The narrator is not accusing anyone of lying. He is pointing out that the language of public space communication has been calibrated for 60 years to keep the program alive, rather than to describe the physical situation accurately. The people inside the program know this. The people writing the press releases know this. The auditors writing the reports know this. The only people who do not know this are the public being sold the confident version. And the deeper issue is not the schedule. The deeper issue is what the Moon was already telling us in 1969 that we chose not to hear. Everything Apollo 11 encountered was already there before humans arrived. The radiation, the dust, the thermal extremes that swing from 120 degrees Celsius in sunlight to minus 170 in shadow within meters of each other. The vacuum that boils unprotected blood. The micrometeorite flux that strikes the surface at speeds no atmosphere has slowed. The biological contamination question that triggered the quarantine. None of it has changed. The Moon has not become safer in 57 years. It is the same body, in the same orbit, with the same physics, waiting in exactly the same way. What has changed is our willingness to remember what it showed us the first time. The Lunar Receiving Laboratory Protocol is the clearest evidence of how seriously the original program took the unknown. NASA spent the equivalent of hundreds of millions of dollars in modern terms building a containment facility for the crew, the samples, and anything that might have hitched a ride. The protocol existed because the planetary protection officers of the era could not rule out, with the data available, that lunar regolith contained dormant microbial life, or organic chemistry that could behave unpredictably in Earth conditions, or contamination vectors nobody had thought of yet. The samples themselves were handled in sealed nitrogen environments. The astronauts were debriefed through glass. The findings were eventually reassuring. No lunar microbes, no exotic chemistry. The samples were inert. But the protocol itself is the artifact that matters. It was built because the agency that publicly projected certainty privately admitted that it did not know. Then there is the Surveyor 3 camera. Apollo 12 retrieved a camera from a probe that had sat on the lunar surface for 2.5 years. When the camera was analyzed back on Earth, technicians reported finding viable Streptococcus mitis bacteria inside. The interpretation was contested. Some researchers concluded the bacteria had survived the lunar vacuum, the radiation, and the thermal cycling for 31 months. Others concluded the camera had been contaminated after return, during handling. The debate has never been fully resolved. Both possibilities are unsettling. Either terrestrial bacteria can survive open lunar exposure, which has serious implications for forward contamination of any future destination, or our planetary protection protocols leak in ways we have not closed. And then there are the bodies. Every astronaut who walked on the moon carries some permanent signature of the visit. A 2016 study in the journal Scientific Reports analyzed cardiovascular mortality rates among Apollo astronauts and found rates significantly elevated compared to astronauts who never left low Earth orbit. The sample size is small, the interpretation is debated, but the signal, in the data we have, is consistent with what radiation biology predicts. Deep space cosmic rays damage vascular endothelium. The damage compounds over decades. The moon marked them, and the mark showed up 30 years later in their hearts. The reinterpretation here is not subtle. We did not conquer the moon. We briefly survived it, 6 times, with margins so thin that any honest reading of the medical and engineering record acknowledges the survival was partly luck. Then we stopped going for 50 years. The reasons we stopped are still the reasons going back is hard. The radiation has not weakened, the dust has not softened, the biology has not adapted, the logistics have not closed. The waiting in the title is not a creature, it is not a relic. It is the environment itself, exactly as it was when the lander touched down, exactly as it will be when the next one does. The moon does not care whether we come back. It will respond the same way it responded the first time. It will push back at every system, every suit, every body, every supply chain. It will find every weakness the engineers postponed instead of solving. So what does the verdict on Apollo's deeper meaning look like 57 years later? Replay the alarm, 12:02. The Eagle is falling toward a field of boulders, the fuel gauge is bleeding towards zero, and Armstrong has the controls in his hands because the autopilot is steering them into rocks the size of cars. 25 seconds of fuel. 2 men. 1 computer that has just told them twice that it is drowning. Listen to that moment again, now that you have heard the rest. The alarm was not a glitch. It was the first thing the moon said to us, and we mistook it for a malfunction. The dust was the second thing. The radiation was the third. The biology, the logistics, the bodies, the institutional softening. Every layer was already speaking, and every layer was edited out of the version that fit on the postage stamp. Apollo 11 was not a demonstration that the moon is reachable. It was a demonstration of the narrowest possible margin under which a human being can briefly stand on another world and come home. That margin has not widened in 57 years. In several measurable ways, it has narrowed. The suits we have now are descendants of the suits that were near end of life after 3 EVAs. The launch cadence we have now is slower than the Saturn V cadence at its peak. The institutional honesty about risk is, by the GAO's own documentation, weaker than it was when Apollo's engineers were writing their post-flight reports. The final illusion to strip away is the simplest one. "We have been there" is not the same sentence as "we can stay there." The first sentence is history. The second sentence is a physics problem nobody has solved. To be clear about what this argument is not, it is not a claim that exploration should stop. It is not a claim that Apollo was faked. It is not a claim that the engineers failed, because the engineers did something extraordinary under impossible constraints, and most of them knew exactly how thin their margins were. It is not a claim that going back is impossible. It is a claim that the physical reality of the moon was harsher than the celebration allowed us to admit. And the same reality is waiting now. If we go back honestly, with the moon's actual difficulty in mind instead of the myth of Apollo, we might survive a longer stay. We will shield deeper than the press releases suggest. We will accept dose limits that look ugly on a public slide. We will design suits the dust cannot kill in days. We will build supply chains that close, or we will admit they do not, and we will stay home until they do. We will fund the engineering memos instead of the press releases. If we go back believing the myth, we will not come home from the second visit the way we came home from the first. The footprints are still up there. Buzz Aldrin's, Neil Armstrong's, 10 other men. Undisturbed. They are undisturbed because the moon does not erase what touches it. There is no wind. There is no rain. There is no biology to reclaim the ground. The prints will outlast every civilization that argues about whether they were real. They are not a monument to victory. They are a record of how briefly we were allowed to be there and how thin the margin was that let us return. The moon never agreed to be conquered. It tolerated 6 visits. It marked the men who made them. It is waiting exactly as it was for whoever comes next. The alarm is still going off. We just stopped listening for it.